Level 0, the ghost. Level 0 doesn't begin with a star. It begins with a theory. Right after the Big Bang, the universe was a violent, blazing soup of energy. Scientists believe tiny, superdense regions in that chaos may have collapsed under their own gravity. The result? Primordial black holes. Some could be smaller than an atom, yet heavier than a mountain. We've never seen one. They may still be drifting through space, invisible, possibly making up part of dark matter itself. They are the ghosts of the cosmos. But to find a black hole we can actually observe, something bright must die first. Level 1, the star corpse. Level 1. Take a massive star, at least 8 times heavier than our Sun. It burns through its nuclear fuel. Then, suddenly, the fire goes out. Gravity wins. Instantly, the star's core collapses in less than a second. The outer layers explode outward in a supernova, one of the most violent events in the universe. What remains, if the core is heavy enough, is a stellar mass black hole. Several suns crushed into a space smaller than a city. These are the most common black holes in the universe. Millions may be drifting through our galaxy right now. Some have companion stars. When a black hole steals gas from its partner, that gas spins faster and faster, heating up until it glows with powerful X-rays, right before disappearing forever. We don't see the black hole. We see the final scream of its meal. But these are only the small ones. The real giants live at the center of galaxies. Level 2, the middleweight. For decades, astronomers faced a mystery. We had small black holes from dead stars, and enormous ones in galaxy centers. But where were the medium-sized ones? The answer lies in the most crowded places in the universe, dense star clusters. Here, gravity turns chaos into a game of collisions. Stars slam together. Black holes merge. Over billions of years, through repeated mergers, a new class emerges. Intermediate mass black holes. They can weigh anywhere from 100 to 100,000 suns. They are the missing link, proof that black holes grow by consuming each other. But to become a ruler, you need an entire galaxy. Level 3, the Galactic King. Level 3, the King. At the center of almost every large galaxy, including our own Milky Way, sits a supermassive black hole. Not just big, unimaginably massive, millions, or even billions of times the mass of our Sun. Ours is called Sagittarius A star. It's relatively quiet, but its gravity is the anchor holding our galaxy together. Every star you see in the night sky, including our Sun, is slowly orbiting this invisible giant, 26,000 light-years away. But some kings are not quiet. When supermassive black holes feed, they ignite the brightest objects in the universe, quasars. A feeding black hole can outshine every star in its galaxy combined. That light is the final glow of matter being torn apart before crossing the point of no return. These black holes don't just live in galaxies, they shape them. Yet there's a problem. We see gigantic quasars in the early universe far too early. They grew up too fast. So how did they form? The answer may lie in the biggest collisions ever witnessed. Level 4 for the cosmic crash, the billion-year collision. When galaxies collide, their central black holes are dragged toward each other. They begin a slow, violent dance, orbiting, closing in, for millions of years, and then, they merge. This event doesn't release light, it shakes the universe itself. In 2015, scientists detected gravitational waves, ripples in spacetime, from 2 small black holes colliding far away. The signal sounded like a brief chirp. A merger between supermassive black holes would be different. A deep, powerful roar echoing through the universe for years. This is how the largest black holes are built. But what happens at the very end? Level 5, the theory. The edge of knowledge. What if a black hole isn't an end, but a doorway? Mathematics allows strange possibilities. Wormholes, tunnels through space and time, with a black hole as the entrance. White holes, the opposite of black holes, where matter can only escape, never enter. Some theories suggest the interior of a spinning black hole could lead to another universe. Others propose something even stranger, that our entire universe may have been born inside a black hole, from a parent cosmos. Here, science becomes speculation, and certainty fades. Which brings us to the final level. Level 6, the fade, the end of forever. Stephen Hawking discovered that black holes are not completely black. Quantum effects at their edge cause them to leak energy, a process now called Hawking radiation. Very slowly, they evaporate. For stellar or supermassive black holes, this takes an almost incomprehensible amount of time. Numbers with 67 zeros. But eventually, they shrink, they heat up, and in the end, they vanish in a final flash of energy. Everything they ever consumed returned to light. From a microscopic remnant of the Big Bang, to a star killer, to a galactic ruler, to one last spark. This is the life cycle of gravity's ultimate victory. From an invisible ghost to the heart of a galaxy, black holes reveal one simple truth. In the end, gravity always wins. And somewhere right now, a star is dying, two galaxies are colliding, and the universe is creating the next one. Subscribe for more.